Hi, in this video I am discussing Edexcel IAL Unit 1 paper WPH1101 October 2021. Okay, question number 1. A graph, two axes are given, the graph is not given, just only the axes are given. Y-axis is named as quantity. So on the answer there are 4 different quantities are given and the relevant gradient also given. We need to identify the correct gradient for the given quantity. So the x-axis is time. So the first answer A, displacement. So we should know what's the gradient of displacement time graph, that is velocity. So under the gradient titled column they are giving acceleration. So we know the displacement time graph, the gradient is velocity. The answer says acceleration. So that is not the correct answer. Answer B, the quantity y is given as velocity. So velocity time graph, its gradient is acceleration. Yes, the answer given in the gradient column of the table, it also given as acceleration. So question number 1, correct answer B. But we will analyze the other two also. Answer C, acceleration is given. The gradient is velocity. So acceleration time graph, there is no specific unit. But area covered by the acceleration time graph gives the change in velocity. Area covered by the acceleration time graph gives the change in velocity. But the question is about gradient. Acceleration time graph, the gradient has no specific meaning. Actually, we don't consider that. Then acceleration against time graph, that also given as displacement, no, so we don't need that also. So the correct answer for question number 1 is B. Okay, question number 2, the second question. Now I'm going to discuss the second question. So there it says a massive star exerts a gravitational force F star on a small planet. So maybe there is a star, there is a planet. So the star exert force on planet, the force is named as F star. Right. The planet exerts a gravitational force F planet on the star. So this is exerting force on the planet is exerting force on the star. Right. But here also they are not telling whether the force is attractive or repulsive. They are not telling in the question. But I marked it because we know there are 4 different types of forces. Gravitational force, electromagnetic force, then contact force, then nuclear force. That's the way we learn in unit 1. But unit 4 is the properly we learn gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. Anyway, force between two masses is called gravitational force. Gravitational force is always attractive. You should know that in unit 1 also. Gravitational force is always attractive. That means if when an object A, which is star, pulls any other objects, a star will pull any other object, any other planet, or any two masses. When you have two different masses, this is mass m1, there is mass m2. Mass m1 will pull the mass m2, so m2 will pull the m1. You know, according to Newton's third law, they will have the same magnitude of force and they will act in opposite direction. Third law pair of forces. So anyway, it's nothing to talk much about it. So here the star is exerting force on planet, which is F star. So planet will exert force on star means that should be towards the planet. Okay, planet will exert force on the star, that is F planet. That's the way they are naming it. That also should be attractive. You know, Newton's third law pair of forces should have the same magnitude. When the object A, I can call it star, object A exert force on object B. Object B will exert same magnitude of force on A in opposite direction. So simple. So the question number 2, the correct answer C. They will have the same magnitude and they will be in opposite direction to each other. That's the answer for question number 2. So the correct answer for question number 2 is C. Okay, question number 3, October 2021, Unit 1 paper. This diagram is given. Two different springs S1 and S2 are suspended from a fixed support. Masses are attached to the bottom of S1 and S2 as shown. The extension of S1 is X and the extension of S2 is X3. The elastic strain energy in spring S1 is E. Which of the following is the elastic strain energy in spring S2? Okay, so you know the according to Hooke's law, the tensile force exerted on a spring and the extension are related by F equal K delta X. There should be minus sign, minus K delta X. We don't consider the minus sign because that shows the direction, because the Hooke's law says force exerted by the spring. So force exerted by the spring and the extension of the spring will be in opposite. So anyway, we don't need any of those signs. We can say the force exerted by the spring of tension on the spring. If I say F, K is the spring constant, delta X is the extension, general equation. So the K is called force constant and it depends, Hooke's law constant, we can say spring constant. So K is the spring constant. K depends on the type of material of the wire used to make the spring, and also it depends on the dimension, thickness of the wire, whatever it is. But elastic strain energy has an equation. Elastic strain energy is given by half F delta X, E is given by half F delta X. So delta X is the extension, F is the force. For spring S1, if I calculate, I'll write clearly. MCQ, we don't need to write anything like this, but just for your understanding, I'm writing everything clearly. For spring S1, if I write, the energy stored in it is given as capital E in the question. So E is equal to half the force exerted on the spring. So a mass M is attached and the spring is at rest. So you know the tension acting on the spring will be equal to mg, the mass times g, gravity, that gives the tension. So half mg and the extension is given as x. So that is the energy stored in spring S1. For S2, we will write, for S2 if I write, the energy stored in it, I need to find in terms of E. So I'll call E1 is equal to half F delta X. That's the equation, half F delta X. For the spring S2, the force acting on it, or the tension of the tensile force of the spring will be 2 mg. The mass attached is 2m. So the tension will be 2 mg into 2 mg into the extension is given as x by 3. Okay, so I need to relate E1 to E, because that's the question. I need to give E1, the energy stored in the spring S2, in terms of the energy stored in spring S1, which is given as capital A. Okay, now physics over, now mathematics, simple algebra. So we'll rearrange it such that E1 to get in terms of E, half mgx is there. So I'll try to get that one, half, right? I'll write this half, this mg into x. Okay, I'll write that first. Into the remaining is, the 2 is remaining, 2, the 3 is remaining, 3. That's all. That's. So half mgx I know E into 2 by 3. So the answer 2E by 3. So energy stored in spring S2, which is E1, is equal to 2E by 3. Correct answer C. Okay, so question number 4. This diagram is given. A tennis ball is moving through the air. The diagram shows the horizontal and vertical components of its velocity. Okay, so this is the velocity. Actual velocity is this one. So we name it as, the diagram says velocity written. So I'll name it as V, that one. So it has both horizontal and vertical components. So it's projected at an angle like this. The angle also given 22.6 degree. So its horizontal component is 13.2 and the vertical component is 5.5. The question is, which of the following expressions give the magnitude of the velocity in meter per second? Simple actually. So there I can try different things. So for example, since I know the horizontal component, if you resolve it horizontally, it will be V cos 22.6 must be equal to 13.2. So V should be equal to 13.2 divided by cos 22.6. Is the answer anything like this? Check it. V equal 13.2 divided by cos 22.6. There is no such answer. But if there is answer like this, it's a correct one. So there is no such answer. Okay, this is one. When I resolve horizontally. When I resolve vertically, so I should write V sine 22.6 must be equal to 5.5 meter per second. So V is equal to 5.5 divided by sine 22.6. Check whether there are any answers like this. 5.5 divided by sine 22.6. Yes, that is the answer C. So correct one for this one, answer C is the correct answer. In case if this is given, that will be the correct. Or they can give one more method, we can find the V, right? This is the correct answer. This is not given, so with sine, whatever they gave is wrong. So this is the correct answer. But in case this also a correct one, V squared equal to Pythagoras theorem. Resultant of these two components. So you should have learned that in vectors, when a vector is resolved, if there's a vector A at an angle theta, its horizontal component, I can say AH, I'll call it as AH, is equal to A cos theta. The vertical component, if I resolve it vertically, AB equal to A sine theta. Right. After that, the resultant of AB and AH, that is A squared is equal to AH squared plus AB squared. That also correct. A squared, the actual vector, square of it is equal to square of the horizontal component plus square of the vertical component. Because you know, if there's a vector A that is equivalently correct to at an angle theta, it has a horizontal component AH, it has a vertical component AB. The resultant of these two must be equal to actual vector, the given vector A. So when you consider the Pythagoras theorem here, AH squared plus AB squared must be equal to A squared. Okay, so if I use that idea here, there could be a third correct answer they would have given. V squared equal 13.2 squared plus 5.5 squared. Therefore, V is equal to square root of 13.2 squared plus 5.5 squared, square root of it. So, in future, there could be a question like which one is not the correct answer like that. They can change the question. They can give this one as a answer A. They can give this as answer B. For example, I am saying this could be answer C and answer D could be something else. And they can ask which expression is not giving the velocity V. Right? So there are three different ways we can find the V if we know the horizontal and vertical components with the angle. If I know, we can find the V in three different ways. Right? But here the question is not that. Here this is not given. Right? This is given, so correct answer is C. So for question number 4, the correct answer is C. Okay, so question number 5. These 4 diagrams are given. A beam is supported by a pivot as shown in the diagrams. The center of gravity of the beam is G, where the weight acts. The beam is acted on by a force F. Which diagram shows an arrangement where the beam could not be in equilibrium? So you know, if a beam wants to be in equilibrium, we'll consider the moment about the pivot where the fulcrum is kept. So the two different forces. So only one force is marked on the diagram. We can take the second force, that is the weight. So the weight of the beam is acting at here mg, here also mg. So everywhere the weight will act from the center of gravity or center of mass. Right, okay, we'll consider the moment about the pivot where the fulcrum, the beam is kept. So if you take moment about this point here, we take moment about this one, this will provide anti-clockwise moment, weight will provide clockwise moment. So they are in opposite direction, only thing they need to balance, they could balance, so it could be at equilibrium. When you consider the B, this will provide a clockwise, anti-clockwise moment about the pivot, the weight will provide anti-clockwise moment. This also will provide anti-clockwise moment, both kinds same direction, so they can't balance each other. So it won't be at equilibrium. We'll check the other two also. If we consider moment about this one, the weight will provide anti-clockwise moment, the force will provide clockwise moment about the fulcrum, the pivot. So it could be at rest if the two moments are same magnitude, opposite direction. They are in opposite direction. If they have same magnitude, then they will be in at equilibrium. Same way here also, the weight will provide anti-clockwise moment, force will provide clockwise moment. So this also could be at equilibrium. So the correct answer where the beam cannot be at rest is answer B. So question number 5, correct answer B. Okay, question number 6, this diagram is given. The block of wood is stationary, so at rest means the resultant force is 0 and the given forces are balanced. Stationary on a frictionless ramp, so there is no friction, right? The block is held in place by a string, so that provides the force F. The weight of the block is W. The force applied to the block by the string is F, but that's the tension. A triangle of forces can be used to determine the material direction of the normal contact force N. So the normal contact force, if I mark it, it should be perpendicular to the contact surface and should pass through the center of mass. Okay, so it will be like this. So this is the normal contact force, the normal given by the plank or the slope on the box. Which of the following triangles is correct? Okay, something related to vectors. First, you should know any forces could be shown by a straight line with an arrow. The length represents the magnitude of the force, and when you are drawing the vector diagram, the alignment or orientation, the alignment of the vector, the line you are drawing should be parallel to the actual force acting on the object. So these are the three forces acting on it. And remember that the second vector should be started from the end of the first vector. The third vector should be started from the end of the second vector. Fourth vector should be started from the end of the third vector, and so on when there are system of forces. So here there are only three forces. So the second, you can start anything as the first vector, whether you can start weight or force or normal rate, anything could be taken as the first line you are representing in your vector diagram. The second one should be from the end of the first one. Third one should be from the end of the second one. That's the way we should draw. But here we know that since the system, the box is at rest, there is no resultant force. That means when we complete the vector diagram, it should be a closed triangle. That means the third vector should end at the starting point of the first vector. We should get a closed triangle without any resultant force. Okay, we'll draw. So I'll start with the weight. So the weight should be drawn vertically down, W. Here I don't have any numerical value, so I'm just sketching. W should be drawn vertically down. The second vector, the force F, I should draw parallel to this one here, or I can draw the normal reaction this way. Either one I can draw. Let's draw the normal reaction. We'll see. Then we can rearrange to get the parallel required one. So W is here. The normal reaction should be, I'll draw the F second, that's easy. This is the W, sorry, this is the weight. The second force, F, should be drawn from the end of the first one. So F should be drawn something like this. It's parallel to line. So eye level, I am drawing a force F this way. That's the second force, F. End of the first, I drew the second one. Third one should be started from here. When I start from here, if I have numerical value and angles, everything, if I know, when I start from here, it should end up here because it is an equilibrium rest. I should get a closed diagram, closed triangle. So the third one should be, the normal reaction should be started from here, perpendicular. So you know this force and these are perpendicular. So I can draw a perpendicular line, something like this. I need to extend sometimes. So the weight should be something like this. right? The arrow should be this direction. So the arrows exactly parallel to the actual forces. So are there any diagram like this? Yes, that is the answer A. The correct diagram is answer A. Okay, so question number 6, correct answer A. Okay, question number 7, a ball bearing falls vertically from rest through a distance of 50 centimeters in a time of 0.32 seconds. Which expression gives the acceleration of the ball bearing in meter per second? Okay, sorry, meter per second square. So what are the given quantities? We know the initial velocity is 0 because it's falling from rest. And we know the distance traveled 50 centimeter. That means it could be 0.5 meters. Normally we want to get the acceleration meter per second square, means the distance fallen, that is the displacement, should be in meter. And we know time t equal 0.32 seconds. The question is, what is the acceleration? So which is the suitable equation that we can use to find the A? By using these given data or given quantities, S equal ut plus half at square. We can use S equal ut plus half at square. S is 0.5, u is 0 plus half a into t squared 0.32 square. Cross multiply. If you cross multiply 0.5 into 2 will be 1. So 1 equal a into 0.32 square. So a is equal to 1 over 0.32 squared or 1 divided by 0.32 squared. So correct answer A. Question number 7, correct answer A. Question number 8. Question number 8. A crane lifts a container of weight 4 into 10 to the power 5 Newton. So the weight is given mg. The weight is given mg. You know, mass times g is the weight, that is 4 into 10 to the power 5 Newton. 4.0 into 10 to the power 5 Newton given, right? And the height through which it's moving also given 25 meters. So the question is, which of the following gives the gravitational potential energy gained by the container? So mg, it's gaining GPE, gravitational potential energy is given by mgh. So mg is given 4.0 10 to the power 5 into h is 25. Okay, so you don't need to solve the expressions, only they are asking. So the correct expression is B. So question number 8, correct answer B. Okay, question number 9. A student measured the terminal velocity of different objects as they fell through a liquid. The student used the measurements and Stokes' law to calculate the viscosity of the liquid. For which of the following conditions Stokes' law apply? So we know that it's normally we teach in the class, everyone should know this, the conditions to use Stokes' law. The object should be a spherical shaped object and the fluid flow around it should be laminar flow, should not be turbulent flow. Laminar flow or streamline flow is allowed but should not be a turbulent flow. So the correct answer A. Question number 9, correct answer A. That normally we teach and all students must know that. Okay, question number 10. A diagram is given, a rocket. The forces acting on the diagram of a rocket are shown. So there is a thrust upward direction given, and also the weight of the rocket is given mg, and also the d, the drag force. D is the D is mass m, acceleration upwards with acceleration a. The diagram represents the forces acting on the rocket. Which of the following equation gives the value of d? Right, so the d is, we need to find it. Okay, so I think it's D's drag, yeah, not mentioned. It should be because thrust is upward, T, this is the weight, this is the D drag force. Okay, so its acceleration also given as A, so the rocket is accelerating upwards at A. So you know that Newton's second law, when we should think about the resultant force acting on it. So there are three forces acting, T upwards, mg down, D down. But it's accelerating upward means the resultant force should be upwards, is it? It's accelerating upward means the resultant force should be upwards. According to F equal ma, F is the resultant force. So we can use F equal ma upward direction. F should be T minus mg minus D equal ma. Okay, so we need to find the D as subject. So make the D subject. D is equal, bring it to the right, bring this to the left. T minus mg minus ma. So m common, you can take the m, take it out, yeah. T minus mg minus D equal ma, yes. Take the minus T out, minus m out. If I take it, G plus a. Take the a minus m common, G plus a. Yes, correct answer D. The correct answer is the fourth answer. So D is equal to T minus, take the m out, G plus a minus out. So minus mg minus ma. So the correct answer is the fourth answer, which is D. Correct answer is fourth answer, which is D. Okay, question number 11, section B, structure questions. Mass of the car is given 0.16 kilograms. Speed of the car at the bottom of the slope is 2.6 meters. So their question says a toy car is released from rest and rolls down a slope as shown. So a toy car is released and it's moving down a slope. So the initial speed is 0. At the bottom of the slope, the speed is given, which is 2.6 meter per second. Right. Calculate the increase in kinetic energy of the car as it accelerates down the slope. Increase in kinetic energy. So we know that increase in kinetic energy means final kinetic energy minus initial kinetic energy. Half mv squared, that's the final kinetic energy, minus half mu squared. Okay, so half, the mass is given as 0.16 into 2.6 squared minus half. I don't need to calculate because initial speed is 0, so I can say the initial kinetic energy is 0. It was at rest, it was released from rest, so initial kinetic energy is 0. So when you solve it, you'll get 0.541 joule. That's the answer for the A part. Okay, so the B part, as the car accelerates down the slope, the work done against frictional force is 0.26 joules. Calculate the vertical displacement of the car. Vertical displacement. So the car was released from here, the car is reaching the bottom. So what is the vertical displacement? So the question is, we need to find this height, how much it moves down. This height, the vertical displacement, we need to find it. So here, we'll use the energy equation for that. Okay. And the work against the friction is given as 0.26 joules. So we can write the proper energy equation for B part. Loss in gravitational potential energy, because there is no motor, electric motor, nothing. So it's moving because of gravity or the gravitational pull. So when something moves down, it will lose gravitational potential energy. So because of losing gravitational potential energy, it's moving down along the slope. So it's losing the gravitational potential. Losing gravitational potential energy is equal to, it's converted to two different factors. One is the kinetic energy. The speed is increasing, but not all the loss in GPE becomes Ke. That could happen. All the loss in GPE will become gain in kinetic energy if there is no work done against friction. If there is no friction, all the loss in GPE will become gain in kinetic energy. But there is work done against friction. So the loss in GPE is going to be shared between gain in kinetic energy and work done against friction. So loss in GPE equal gain in Ke plus work done against friction. FR, our friction, I write full working, friction, work done against friction. So loss in GPE, we need to find it, that is NGH, we'll substitute it. Gain in kinetic energy, we know 0.541. Work done against friction is given in the question, which is 0.26. Mass we know that, which is 0.160 into 9.81 into H equal to 0.541 plus 0.26. Okay, so solve it and find the H. You know how to solve it. Add these two quantities, from that divide. That quantity should be divided by this multiplication. And when you know how to find it H, you will get 0.51 meters. Okay, question number 12. An aluminium sphere collides head-on with a stationary steel sphere. The diagrams are given. The two spheres move off separately after the collision. So they are giving it on the diagram. All information is something like IGCSE question, not a big problem. A part, state the principle of conservation of momentum. You can find it from any book. All of you know that. We can say when there are no external force such as friction, the initial total momentum will be equal to or must be equal to final total momentum. When there are no external force such as friction, normally it's for a closed system, is it? So that law of conservation momentum is not a problem. I'll go to the part B, the calculation. So all the diagrams are given. So the before collision aluminium sphere is moving towards right at 10 meter per second and its mass is 2.7 kilogram. The steel sphere, which has mass 7.9 kilogram, initially at rest. After collision, the steel sphere is moving towards right at 5 meter per second. The aluminium sphere, its velocity is shown on the diagram towards right, V. I need to find the V. I might get V negative because the aluminium sphere, which has lower mass, could bounce back. We'll see what we are getting. So I'm going to use the law of conservation of momentum towards right. So B part. So law of conservation momentum, I'm using it towards right. Okay. So the aluminium sphere, the mass is 2.7. So mass into 10, the velocity of the aluminium sphere. The steel sphere is at rest, so its initial momentum is 0. After collision, I'm using it towards right. I'm taking momentum towards right is positive. If the velocity is towards right, you know momentum and the velocity are always parallel vector. So I'm taking towards right, positive. Okay, so after collision, the velocity of the aluminium is shown towards right. I'll accept it as correct. So I'll put it towards right V. If I get negative answer for V, that means the velocity is towards left. The aluminium sphere bounced off from the steel sphere. We'll see. After solving it, we'll see that. plus the steel is moving towards right, because steel moved towards right, 100% sure, because steel was at rest initially, and the aluminum sphere AL, this is steel, so aluminum sphere is hitting the steel, so when it hits which was at rest, will move towards right. So 100% sure the steel is towards right, the velocity. So for the steel sphere, the mass is 7.9 into its velocity 7 after collision 5. Okay, solve it. You know how to solve it. Find the V. This minus this divided by 2.7. You will get minus 4.63 meter per second. That is, I took it towards right, which is minus, means 4.63 meter per second towards left. So the question is calculate the velocity. So direction is important, towards left. Okay, question number 13. A sledge accelerates due to gravity from rest down frictionless slope. So there's no friction, frictionless slope. Air resistance can be ignored, so no drag force also. The slope is at an angle 6.9 degree to the horizontal. A part, complete the free body force diagram below for the sledge. So there will be only two forces, because no friction means if I mark it here, so but they asked to mark it on a dot, so they give a small like a dot for the that represents the sledge. There are two forces acting on it. One is the weight. The weight is acting vertically down, which is mg. So, and the normal reaction will be perpendicular to the slope. If I consider the slope something like this, it could be perpendicular, and the angle, how much will it be, the angle of the normal reaction with the vertical. So you can think about the weight is this way, this is the way the weight is acting, mg. The normal reaction will be this direction, which is perpendicular to the slope. This is the normal reaction, we can call r, or yeah, normally we put r. Okay, so how much will be this angle? This angle, how much should I mark? So here I know the normal reaction, I should mark perpendicular to the slope, something like this, normal reaction. We name it R. What should be the angle here? Okay, we'll calculate it. So in this right angle triangle, this is 6.9. So if I extend this line, this will be 90 degree. So this will be 90 minus 6.9. This in this right angle triangle, this is 90. So you know the total addition of the internal angles will be equal to 180. So this is 90 means this plus this should be 90. So this will be 90 minus 6.9. I am not going to calculate. 90 minus 6.9. But I know the normal reaction which is perpendicular to the slope. So this is 90 degrees. So this angle will be, this angle and this angle are opposite angles. So they will be the same. So this angle will be 90 minus 6.9. So that is going to be 6.9. So remember that this angle 6.9 degree. I hope you understood. In this right angle triangle, even if they call this as theta, this is 90. So this will be 90 minus theta. Remember that, 90 minus theta. Because this total angle, the addition is 180. This is 90. So this is theta. In case if they say this is theta, this will be 90 minus theta. The normal direction R is perpendicular to the slope. So this is 90 minus theta, means the line, the angle between this blue color and black color is 90, the total angle. So this will be 90 minus theta. So that will be theta. So whatever the angle given will be the angle here. Okay, so that's the reason I mark it as 6.9 here. Okay, so the B part, the slope has total length of 60 meters. So the length from here to here, this length is 60 meters. That is 60 meters. show that the initial acceleration, that's the A part of B part, show that the initial acceleration of the sledge along the slope is about 1 meter per second squared. So there we need to find the initial acceleration, means we know the weight is acting vertically down, this is mg, and we know the angle of this weight with the vertical line, this is 6.9. So the component of the weight along the slope will be the component of the weight. That's the only force acting along the slope, because normal reaction is perpendicular to the slope. So the normal reaction won't have any component along the slope because that is perpendicular to the slope. This angle is 90. You know, when a vector is resolved through 90 degree, it won't have component. You would have learned that vertical vector has no horizontal component. Horizontal vector has no vertical component. The reason is you are resolving it. If you are resolving a vertical vector to horizontal component, if you try to find the horizontal component of a vertical vector, you are resolving it through 90 degree. There won't be any component because cos 90 is 0. Same way, if there is a horizontal vector, it won't have any vertical component. They are also, you resolve it through 90 degree. Not only horizontal, vertical. If there is a vector A, if there is a vector A at an angle A, and if you try to resolve and find its component along this direction, perpendicular to that one, this is 90 degree. What is the component of this vector along this direction, which is perpendicular to this one, means the component will be equal to 0. Remember that when a vector is resolved through 90 degree, it won't have any component. Not only horizontal vector has no vertical component, vertical vector has no horizontal component. Yes, that's true. But generally, when a vector is resolved through 90 degree, it won't have any component. Okay, so here the normal reaction is along this way. It has no component along the slope because normal reaction is perpendicular to the slope. So the only force acting on the sledge along the slope down is weight. The weight is making an angle with this line 6.9 degree. So I need to resolve this weight along the slope, means mg sine 6.9. So along the slope I am going to use F equal ma. The only force acting along the slope is mg sine 6.9 equal ma. M and M will get cancelled. So A is going to be g sine 6.9 meter per second squared. So we know 9.81 sine 6.9 meter per second squared. So solve it, you will get 1.18 along the slope down, that is along the slope down. So approximately 1 meter per second squared. Okay, so B part. So the question is about B part. B part, this is B part first part. This is B part first part. B part second part. Find the speed or determine the speed of the sledge at the end of the slope. Okay, we can find it in two different ways. One, we can, since we know the acceleration, I can use along the slope down. I am using it along the slope down, means I should put the diagram like this, the direction along the slope down. I'm going to use, we are need to find the speed. So they ask you to find the speed, means I can use v squared equal u squared plus 2as. So I'm going to use this equation because I know the acceleration, I know the distance is going to move 60 meters. So this is the method 1. So v squared I need to find. It was starting from rest, 2 into acceleration along the slope is 1.18 into the distance it moved is 60. Solve it and find the v. You will get 11.9 meter per second. This is method 1. Method 2, I can find it by using energy equations. This is method 1. Method 2, I'm going to find it by using energy equation. There is no friction. So the height, it has fallen down. So when it moves along 60 meters along the slope down, what will be the height it's moving down? I need to find this height h when it moves from here to here along the slope 60 meter. What will be the height h? I can find it by using simple trigonometry, that is h is equal to the height it has fallen down is in this right angle triangle, h is equal to 60 sine 6.9 meters. So that will be 7.21 meters. That's a vertical height. So then I can write loss in GPA, gain in K. Earlier we came across that type of approach, but there was friction, question number 11, but here no friction. So I can say loss in GPA, loss in gravitational potential energy equal to gain in kinetic energy, because there is no friction. So plus work done against friction I don't need to write because it's a frictionless surface. The sledge is moving on a frictionless surface. Loss in GP mgh, gain in kinetic energy half mv squared minus half mu squared. But we know initially it was at rest, released from rest, so half mu squared equal to 0. So I'll just put half mu squared as 0. So m will get cancelled. So g into h, g is 9.81 into h is 7.21 equal half v squared, because m got cancelled. So find the v squared. So solve it and find the v, exactly the same answer. You will get it 11.9 meter per second. So either way we can approach by using equations of motion or by using energy equations. One of the way we can do. Okay, so the third part, determine the time taken for the sledge to travel to the end of the slope. So we know the final velocity, we already found it, one of the method as I told earlier. I know the distance it moved, so I need to find the time taken. So I know the acceleration along the slope down 1.18, initial speed 0, so I better use v equal u plus at along the slope down. So v 11.9 starting from rest, acceleration 1.18 t. Find the t, it will be 10.1 second. Okay, question number 14. A student carried out an experiment to determine the Young modulus of a sample of stainless steel in the form of a wire. The student added weights to the wire and measured the corresponding extensions. The wire had an unstretched length, that is the initial length or natural length, 2.6 meter. The diameter is 5.6, 10 to the power minus 4 meter. The student plotted a graph of weight against extension. The graph showed that the limit of proportionality was not exceeded. So you know force against extension graph should be a straight line under the limit of proportionality. Beyond it, it will slightly curve. You know the next point of the limit of proportionality slightly on the right side is the elastic limit. The first part, the A part, state what is meant by limit of proportionality. So we can say the point, the maximum point of force up to which the force is directly proportional to extension. That's the answer for limit of proportionality, 1 mark. Okay, so B part, there's a graph, weight. Weight means the weight which is hung on the wire or the tension exerted on the wire, that is on the y-axis. X-axis is the extension. Determine the gradient of the graph. You know how to find the gradient. I took 2 clear points. I didn't take 0. It's passing through origin, but I didn't take that as a point. I took 2 different points and I found the gradient. So B part, first part. Take 2 clear points, 26 minus 30 by 2 minus y1 over 1.4 into 10 to the power minus 3 minus 0.7 into 10 to the power minus 3. So that will be, you know, this is Newton, this is meter. So finally I'm getting 1.86 10 to the power 4 Newton per meter. Okay, that is the gradient. Okay, so actually you know what is the meaning of the gradient. You know the y-axis is force, x-axis is extension. So you know that F over A, force over extension, F over delta x. F over delta x, is it? That's the gradient. That is 1.86 10 to the power 4 Newton per meter. Force over extension. Okay, change in force over change in extension, or force over extension, because since the graph is passing through the origin, we can say force, any force, particular force minus 0, is it? Because it's passing through the origin. Force, a particular force on the graph. So this is a graph. Rather than saying change in force, I can say force, this is extension. The graph is passing through the origin. Okay. So there's a force, particular force, F. This is the relevant extension. So the gradient m, we normally denote gradient by m equal f minus 0, f minus 0, if I take the origin. Okay, I didn't take the origin in my answer, but it should be taken because we know the graph is a straight line through the origin. So rather than saying change in force over change in displacement, I can say force minus 0 over this extension is delta x minus 0. So that means force over delta x. For a particular force divided by extension. Particular force divided by relevant extension gives the gradient. Careful the meaning of it. Don't get confused saying that F1 minus F2 over delta x1 minus delta x2. Yeah, that's true, but delta x2 is 0, f2 is 0. Since the graph 100% sure, it must pass through the origin according to Hooke's law, since the metal wire obeys Hooke's law. Okay, so the gradient gives f over delta x. Okay, so f over delta x 1.86 10 to the power minus 4. In case if the graph is not passing through the origin, then I can't say f over delta x. I should say change in force over change in extension. Careful, if the graph is something else somewhere, if the graph is not passing through the origin, then I can't say the gradient is f over delta x. Then the gradient will be change in force over change in extension. But here the graph is passing through the origin. That's the reason I am saying for a relevant force over, or for a particular force divided by the corresponding extension is the gradient. Okay, I hope you understood the meaning of the gradient here. Okay, so F4 delta x is this one, that is the gradient. Okay, so second part, determine the Young modulus of the stainless steel using your value for the gradient. So I'm going to use that gradient here. See, the purpose of it is I'm going to use this here. So actually this, for the second part, I'll put the second part here because the meaning of the first part, they asked to find the gradient. So I wrote first the meaning of the gradient at the start of my second part. Okay, so we know that Young modulus equal tensile stress over tensile strain. Tensile stress means force over area over tensile strain means extension over original length. So that will be F x over A delta x. I will rearrange it such that I get the gradient. So this I am going to write F over delta x times x over A, that is E. I hope you understood the rearrangement, simple algebra. I'll get fx over A delta x, but I know f over delta x is the gradient. I already explained that one. So I'm going to get the gradient in my Young modulus equation. So I'm rearranging this fx over A delta x as f over delta x into x over A. You know, A, B over CD, O level math, A, B over CD is equal to A over D into B over C, I can write, is it? It's nothing confusion, so simple maths, right? Okay, so I need to find the Young modulus. So I know all the things, so I'll continue here. So E is equal to, I'll write again, F over delta x into x over A, but I know A is equal to pi d by 2 squared. Diameter is given, so pi d by 2 squared. So diameter we know that, so I can find the diameter here, radius here, right? F over delta x, we know that 1.86 10 to the power 4 into x, the initial length or original length is 2.6 over area pi d by 2. Diameter is given 5.6 10 to the power minus 4 meter over 2 all being squared. Okay, solve it. You will get the answer, final answer 1.96 10 to the power 11 Newton per meter squared or Pascal. You can give the unit. Okay, so the C part, the breaking stress for this stainless steel is known to be 480 megapascal. That is 480 into 10 to the power 6. Mega means 10 to the power 6 Pascal. Deduce whether it is safe for the student to increase the weight to 100 Newton. Okay, so this we can do it different ways. I can find, say for example, since the braking stress is given, I can find the braking force. How much of force could be the maximum applied to the wire such that it is not breaking. Then I can compare the force what I calculated, the braking force what I calculated with the 100 Newton. If the force what I calculated as the braking force is greater than 100 Newton, then I can say he can attach 100 Newton. Or if it is less than 100 Newton, so that means 100 Newton will be more than the braking force. So certainly the wire will break. So simple thing, we'll do that way. Okay, so the C part, the braking stress equal braking force FB over area of cross section, area equal to pi d by 2 square, that is 5.6 10 to the power minus 4 divided by 2 all in square. You can substitute directly or you can find this area 2.46 10 to the power minus 7 meter square. So braking stress is given 480 megapascal, 480 mega 10 to the power 6 equal braking force, that is the maximum force required to break the material is the braking force over 2.46 10 to the power minus 7. So find the braking force. So that is equal to 118 Newton, which is less than 100 Newton. So he can attach, the student can attach 100 Newton without breaking. So that should be given. Can increase 100 Newton without breaking. Okay, so there could be another method. There we find the stress for the given force and compare with the braking. We could find the stress for the given force and compare with the braking stress. Either way, both same. So if the stress method 2, just find the stress for the given force of 100 Newton. So 100 over area of cross section, same thing you can use 2.46 10 to the power minus 7. So there the stress will be 4.06 10 to the power 8 Newton per meter square. That is, if you give it in mega, that will be 406 megapascal. So the braking stress is 480. So this is less than 480 megapascal. Therefore, the stress not reached the braking stress. The stress for the 100 Newton not reached the required braking stress to break the material. So you can increase the force to 100 Newton. That way also you can give the answer either way. Okay, before discussing the question 15, it is better to discuss about how rotation of wheel of a car moves the car, right? Or how the rotation of a wheel moves the car in forward direction or backward direction. You know, normally in two-wheel driven car or four-wheel driven car means the two-wheel driven car means two wheels are connected to the engine crankshaft, or four-wheel driven car means all the four wheels are connected to the crankshaft. Whatever it is, the engine rotates the wheel, that's all. Engine never moves the car. Engine rotates the wheel. So which force moves the car? The friction between the tire and the ground, or friction between the tire or wheel and the road. That friction, the friction acting at the contact point of the wheel and the road, that friction moves the car forward, not the force by the engine. Okay, so anyway, but I'll first explain that one, then I'll go to the question 15. So for example, imagine a car, something like this. Okay, so name this point where it's contact with the rear wheel. The car is moving this direction. This is the direction of motion. This wheel Y. Okay, we'll assume the is a rear wheel driven car. Only the wheel X is connected to the engine or connected to the crankshaft. So the front wheel is not connected to the engine, but the front wheel also will rotate when the car moves. Okay, so the back wheel connected to the engine means engine will rotate only the rear wheel, the pair of rear wheels. They will be rotated by the engine. So if the car wants to move this direction, I'll draw the wheel X alone. This is the wheel X. That will be rotated by the engine this direction. So the point where the wheel is touching the road is X. I'll draw the road separately. This is the point X. Okay, the wheel is rotating. Now look at here. If the wheel has no grip, or if the wheel has no sufficient friction, the wheel will just rotate. When the wheel just rotates, the car won't move because the wheel will slip and rotate without pushing the ground. But if there is friction, what will happen? When the wheel, if there is sufficient friction between the point, between the road and the wheel at point X, right? At point X. So this is the rear wheel. I'll call the rear wheel as wheel A. This as wheel B. I am drawing for wheel A. The point where its contact is X, right? This is the point X, contact. So I drew the X on both, where the wheel and the road. Okay, so the wheel is rotating that direction. So if there is friction, what will happen? This point, think about this thing. This point will try to move towards this point will try to move this direction. But friction will not allow it. So that means the wheel will push the ground. The wheel will push the ground because it's moving this way. It will push the ground to the left. So the wheel will push the ground, that is the friction, towards left. Friction. So the ground will push the wheel forward direction. Newton's third law, pair of forces. So actually what's happening, the wheel is pushing the ground at point X to the left because the point X is trying to slip, but it couldn't slip because there is sufficient friction. It's pushing the ground to the left, so the ground is pushing the wheel forward. This force is the forward thrust for the motion of the car. Because I told only the rear wheels, a pair of rear wheels are connected to the engine. Okay, so the car will move forward because of this force. So this force is the friction that is pushing the car in forward direction. Okay, so because of the friction. So when the car moves forward, now what will happen? Think about the wheel B. Think about the wheel B. So the wheel B is touching the ground at point Y. So I'll draw that also separately. So the wheel B will try to slip on the road. So the wheel B, because the car is moving forward because of this force, because of this friction at X, which is connected to the engine, the rear wheel, the car is moving forward. When the car moves forward, the wheel B will try to slip on the car, but there is also friction. So when it tries to slip on the road at point Y, the car will exert a force this direction. the road will exert a force on the wheel towards this direction, because the wheel is trying to slip on the road. So when it tries to slip on the road towards right, the road will exert a force, a contact force, a friction force at point Y, this direction. It's also friction. I'll put it F dash R. So when the road exerts force on the wheel this direction, this is the point where the armature is there. So when there's a circle, you take a coin or something like this, hold it at the point and push this direction. What will happen? The wheel will rotate. So that's the reason the front wheel rotates this direction. So the reason for rotation of the front wheel is the friction exerted by the road on the front wheel. The front wheel is not connected to the engine. So friction exerted by the road on the wheel at point, the contact point, this way makes the front wheel to rotate this direction. Okay, so this is the driving force which is given by the engine. Okay, so actually given by the friction from the road. So again I am telling, the engine rotates the rear wheel. Rear wheel is connected to the engine. So it rotates the rear wheel A. When the rear wheel rotates, what happens? Due to friction, the rear wheel will push the road backward direction, because it's rotating this way at contact point. It will push the road towards left due to friction. Road will push the rear wheel forward direction with the same force Fr. So this force is the forward thrust to the car. Now the car will move. When the car moves, the front wheel will try to slip on the road, but there is friction between the front wheel and the road at the contact point Y. So at the contact point, when the front wheel try to slip, the road will exert a friction this direction, because slipping this way, try to slip to the right. So at the contact point, the friction will oppose the possibility of slipping. It exerts a friction this way. The wheel is pivoted, or there's armature at the center. So wheel will rotate in this direction. So the front wheel will rotate this direction. Okay. So the acceleration of the car depends on this friction. This friction depends on the type of the tire, the grooves on the tire. So many factors decide the friction between the road and the tire. Okay, also you should know that whenever the wheel rotates only, there will be the friction between the road and the wheel will exist. So when the rate of rotation of the wheel is higher, the friction will be higher. The wheel will experience more force, right? So the higher the rate of rotation of the wheel, so when the engine, when we accelerate the car, we are increasing the rate of rotation of the wheel. So when the rate of rotation of the wheel increases, the friction between the road and the tire also will increase. So the forward thrust to the car will increase. So remember that the rate of rotation, because whenever the wheel try to rotate, or whenever the wheel has intention of slipping only, there will be the friction force. So when the rate of rotation of the wheel increases, the friction between the road and the tire also will be higher. So, but we assume that is within the limit of friction, but that's not in the syllabus. But when the friction increases, when the rate of rotation increases. Okay, so in this question, the photograph shows a toy car that contains a spring. Pulling the car backwards along the floor compresses the spring. Energy is stored in the compressed spring, so we know that's the elastic potential energy. The car is released and the spring returns its original state. There is a forward force on the car from the floor and the car moves forward direction. So the forward force, the question says there is a forward force on the car from the floor, right? Actually here also the car, we don't know the actual technology inside the car, how the spring is moving the car, but actually the car is moving forward because of the rotation of the wheel. So rotation of the wheel is due to the compressed spring. So the compressed spring, when it returned to the original length, it's rotating the wheel. How? We don't need that technology. We don't need how the compressed spring return, when the compressed spring returns to its original length, the technology makes the wheel to rotate. So when the wheel rotates, the car is on the floor, so there will be friction between the wheel and the road or on the floor. So the wheel, when it rotates, as I explained, the contact point, the wheel will try to slip, but due to friction it's unable to slip. So the wheel will push the flow backwards, flow will push the wheel forward. But remember that this force, the friction here also depends on rate of rotation. If the wheel is rotating, for example, 20 times per second, the friction will be more compared to when the wheel rotates just 5 times per second. Okay, higher the rate of rotation, greater the friction. Right. So there is a forward force on the car from the flow and the car moves forward. That's given in the question. Explain why the flow exerts a forward force on the car and how this force affects the motion of the car as the spring returns its original state. Okay, so here we know that initially the spring is fully compressed. So when the spring is fully compressed, the force exerted on the spring, or the compressive force on the spring, F equal K delta X. So delta X is larger initially when it is fully compressed. The force or the compressive force on the spring is larger. So I told the technology we don't need, but that compressive force is rotating the wheel. So the rotating wheel has a larger force exerted by the spring. Careful. This force is given by the spring to the wheel. So the rate of rotation of the wheel will be initially high. Because you know, you can think about force higher, wheel has mass, so the rate of rotation will be more because acceleration will be more. Circular motions, I don't need to go into detail. Actually, angular momentums we are not considering here. We are not considering the mass of the wheel, so I don't even want to confuse too much by including the angular momentum. But this force F is the force given by the spring to the wheel, so the rate of rotation will be more. So simply we can say rate of rotation more means the friction between the wheel and the floor or ground will be higher. So we should say when the compression is higher, the friction between the wheel and the ground is also larger. So the initially the acceleration of the wheel acceleration of the car is larger because as I told earlier, when the wheel rotates, it will push the ground backwards. According to Newton's third law, ground will push the wheel in forward direction at the contact point. So that force is the forward thrust to the car, so car will move forward direction. Initially the compression is larger, so the friction will be larger, so the acceleration of the car will be larger. When the spring returns to original length gradually, the compression will decrease. When the compression decreases, friction also will decrease. The acceleration of the car also will decrease. Finally, when the spring returns its original length, the compression is equal to 0. Therefore, there will be no forward thrust on the car. So actually the forward thrust means the resultant force is not there. So the car will continue to move at constant velocity. There is no further acceleration. Finally, the car could stop due to friction at the axles of the wheels. So that should be the answer given here. So normally students get confused here. Do they ask, does the compressive force of the spring accelerates the car? No. Actually, compressive force is used to rotate the wheels. The friction between the wheel and the floor is the forward thrust that accelerates the car. Okay, so actually not the compressive force on the spring is accelerating the car. No, the compressive force is rotating the wheel. The rate of rotation provides the required. So you can have a situation like this. You can compress a spring, the same car, just compress it and keep it on a perfectly smooth floor. The wheels will rotate, but the car won't move. Car won't move, because if there's no friction between the flow and the wheel, the car won't move. Or you can put oil on a smooth tiles floor and compress, do the same thing what mentioned in the question, compress the spring of the car and keep it on the floor. What happens? The wheel will rotate, but the car won't move. Okay, so actually the acceleration of the car in forward direction is not because of the compressive force, that is because of the friction between the wheel and the floor. Okay. Okay, question number 16, that is on projectile motion. An explosion projects a rock into the air with a speed of 50 meters per second at an angle to the ground 40 degree. Show that the rock would reach its maximum height about 3 seconds after explosion. So maximum height means the technique we use at the maximum height, the vertical component of the velocity is equal to 0. We'll use that technique at the highest point. When a projectile is projected, it will follow, an object is projected, it will follow a parabolic path. At the highest point, the vertical component of the velocity equal to 0. So initially it's projected at a velocity u at an angle theta. So you can use equation in vertical direction, v equal u plus at. V is the final velocity in vertical direction at the highest point, which is equal to 0. You can find the time taken here. So that's nothing hard, it's very simple. So I'll do the A part, question 16, A part. In vertical direction, we'll use V equal U plus AT up to the highest point. So in projectile motion, it's better to state, when you are using an equation, it's better to state from which point to which point you consider the motion. It will be helpful for the examiner to understand. So the vertical component up to the highest point, so the final velocity at the highest point is 0. The initial velocity, it at angle 40 degrees, so 50 sine 40 plus minus 9.81, because you know the gravitational acceleration is downward direction, I am taking upward direction is positive, into t. So solve it, very simple question. So bring it to the left, 9.81 t equal 50 sine 40. Find the t, you will get 3.28 seconds, approximately 3 seconds. Okay, so the B part, the rock moves in the direction of a hill. The side of the hill is at 20 degree to the horizontal as shown. So the side of the hill is shown as a straight line, a slope that makes an angle 20 degree with horizontal. The projectile is moving at 40 degree with the initial velocity of 50 meters per second at 40 degree with the horizontal. But the hill, the side of the hill, which is shown by a straight line as a straight slope, that makes an angle 20 degree with horizontal line. After a certain distance, the rock lands on side of the hill. So after that, it's hitting the hill, the side of the hill. So it's something like this is the hill, right? So it's also projected from somewhere here. It's following a parabolic path. So it's hitting the hill at a point. But the question is slightly different. I just drew the diagram, not according to the question. I just drew, right? So initially here, finally it's landing on the slope of the hill after certain time, right? Deduce whether the rock hits the ground before it reaches its maximum possible height. So that's the question here. So I drew the two possibilities. So here the projectile is reaching the highest point, then hitting the slope, which makes an angle 20 degree with the horizontal, the slope. Here the projectile is hitting the slope before reaching the highest point. X is the highest point. We don't know. That's the question. Whether it reached the highest point, then hits the slope, the side of the hill, or it hits the hill after reaching the highest point. That's the question. Okay, we don't know which situation happened. The projectile, the explosion, after that the projectile, it hits the hill after reaching its highest point, or it hits the hill before reaching, X is the highest point, before reaching the highest point. That's the question. Okay, so what can we do now here? The idea here, we can do it in there are different methods using the angles, anything, but simple method we'll do like this. Okay, we'll find what could be the highest point, because we know the angle of projectile motion. Initial angle is 40 degree with horizontal. So we'll find what could be its maximum height. What is the maximum height reached by the projectile during its motion? We can find it by using v squared equal u squared plus 2as. Simple that one. V squared equal u squared plus 2as in vertical direction. If you use v squared is 0 because highest point. U squared, you know, 50 sine 40 all in squared, and find the possible maximum height. Okay. Then we will find what could be the time taken to reach the highest point. That we already found it in the first part, 3.28 seconds. So what could be the horizontal displacement when it is at the highest point? This point. We are going to find the horizontal displacement, this one. So this is the horizontal displacement. So if I consider the horizontal displacement, this one. This is the horizontal displacement, SH. Or here also I can say the horizontal displacement when it is at the highest point. SH, we will find it. The horizontal displacement of the projectile, whether it's hitting or not, we don't consider. Just find it without thinking whether it's hitting the slope or not. Just find there is no slope, imagine, and find what could be the horizontal displacement of the projectile when it is at the highest point. It would have hit it before reaching the highest point. Doesn't matter. We'll find it. What could be the horizontal displacement when the projectile reaches its highest point? Imagine there is no slope or anything. Okay, we'll find that horizontal displacement, right? So after that, we will compare that maximum height reached by the projectile, right? The maximum height reached by the projectile with the height of the slope. Say for example, when it has a horizontal displacement of this one, we know the slope of the side, the angle we know. We'll find this height h. This height h, when it is at the highest point, what could be the height? We'll find it. Then we'll compare that height with the maximum height. Then we'll decide whether the maximum height reached by the projectile is more than the possible height of the slope when it has the horizontal displacement of this one. We'll compare it, and finally we can find out whether it will hit or not before reaching the highest point. Okay, so we'll do the calculation. Now we'll find the maximum height reached by the projectile. So vertically use v squared equal u squared plus 2as up to highest point. So at the highest point, the vertical component velocity is equal to 0, and the initial velocity 50 sine 40 all in square plus 2 into minus 9.81, because I am using upward direction. Acceleration is downwards, gravitational acceleration. S is h max, the maximum height reached by the projectile. How much is it? We'll find it. So solve it and find the h max, the highest maximum height. H max is equal to 52.6. Or you can find this by using S equal ut plus half at square in vertical direction, because we found the time taken to reach the highest point. So you can use S equal ut plus half at square and find the S, that is the maximum height for the time of 3.28 seconds. You will get the same answer. Whatever it is, it's okay, no problem. I use V square equal U square plus 2. So this is the maximum height that could be reached by the projectile. Whether it's hitting or not, we don't concern. Just find the maximum height. We found it, right? So when it is at the maximum height, how much should be the horizontal displacement? We know the time taken to reach the highest point. We found it in the A part. So horizontally we will find the horizontal displacement, possible horizontal displacement when the projectile is at the highest point. Okay, we are going to find that. So horizontal use S equal ut plus half at squared. That also up to highest point. So SH, because I use the notation, I use SH, the horizontal displacement, that is 50 cos 40. The time we found it already, that is 3.28. Plus we know horizontally no acceleration, because gravitational acceleration is vertical, that has no horizontal horizontal component, and we assume the no drag force. So horizontally no acceleration or deceleration. So horizontal displacement when the projectile at its highest point, that is going to be 125.6 meters. Okay, now we know if this is 125.6 meter, if this is 125.6 meter, we will find along the slope, now we'll forget about the projectile motion, along the slope, when this is 125.6 meters, 125.6 meters, what could be the h along on the slope of the hill? What could be the h? So we are going to find this h, the height of the mountain, the side, is a straight line. They say it's the side of the mountain is a straight line like a slope. What is the h? We are going to compare that h with the maximum height. Okay, so we'll find that maximum height h. So here this triangle I can use, this triangle I can use, that is tan 20 equal h over, h is the height of the mountain, the slope mountain, h over 125.6. Find the h. When you solve, the h becomes 45.7 meters. So we know that now the height of the slope when the projectile has a horizontal displacement of this one. This horizontal displacement occurs when the projectile is at its maximum position. So when the projectile is at its maximum position, at that position, the height of the mountain, the slope of the mountain is 45.7 meters, but the maximum height of the projectile is 52.6, which is more than the height of the mountain. That means when the projectile is at its highest point, at that position, the height of the mountain is just 45.7. That means projectile is above the slope of the mountain. So the projectile will travel further and hit the mountain. So this is the correct diagram, not this one. In case if I get this height is smaller than, this height is smaller than the maximum height, means it would have happened here. Before reaching the highest point, it would have hit it. But here we found the height of the slope is, the height of the slope is smaller than the maximum. If it happens other way, the height of the slope is larger, I made a mistake. Height of the slope is larger than the maximum height. That means it would have hit it here like this. But here we are getting h is 45.7. The maximum height is 52.6. So this diagram is not correct according to the given data. This diagram is not correct. This is the correct diagram. Okay, because height of the mountain is 45.7. So this is 45.7. when the projectile has a maximum height of 52.6. So that means the projectile will reach its highest point before hitting the slope of the mountain. So I don't need this diagram, I can trace it. So we can give the conclusion that should be written, but I am not writing. So you should write the final conclusion since that we found it earlier, I erased it, sorry, I write it again, that tan theta equal tan 20 equal h over 125.6. So h equal 45.7, which is less than h max 52.6 meters. So we can give the conclusion since the maximum height of the projectile is greater than the height of the mountain at that point, mountain or hill, they are using the word hill, yeah. Height of the hill at that point the projectile will reach its highest point before hitting the side of the mountain. So 52.6 is this height. This is the 52.6. This is 52.6. Okay, so this question 16b part we can do by comparing the time taken. So already we found the time taken to reach the highest point in the first A part, which is 3.28 seconds. We'll find what could be the time taken to hit the side of the mountain, or what's the time taken to hit the slope. Okay, for that, simple actually, nothing hard, not given in the mark scheme, this method. But anyway, there's nothing wrong. You can do this way also, I think, yeah. So you know the technique here. Say for example, think like this. If a projectile is projected on a horizontal floor at an angle, when it returns from x to y, that's the path of the projectile. So if xy is a horizontal floor or horizontal plane, the vertical displacement, when the projectile completes its motion from x to y, the vertical displacement equal to 0. You understood? Because it went away from x, so the vertical displacement is increasing. You know that vertical displacement is increasing. It reaches the highest point, then the vertical displacement is decreasing. You can see that. Finally, when it hits the floor or ground, the vertical displacement will be equal to 0. So we normally use this vertical displacement, which is equal to 0, to find the total flight time when we consider vertically s equal ut plus half at square. We use normally. If the initial velocity is u at an angle theta, we consider s as 0 u sine theta into t plus half. The gravitational acceleration is vertically down, which is g, so we put minus g t squared. So here t squared, we divide the whole equation by t. Then we solve and get the time for the whole motion. Understood? Here important. The acceleration is vertically down, so we put minus g when we consider displacement in vertical direction upwards for the whole motion, but that is equal to 0. Okay, the same way we consider the motion on a slope. What could be the vertical, the displacement? Along the slope, when we consider this way, the projectile is moving from here to here, right? Here it's hitting. We don't know where it's hitting, but we'll take it's hitting the slope at that point. Now consider perpendicular to the slope. We'll consider there, I told when the projectile is from horizontal flow, we consider perpendicular to the horizontal line. The displacement equals 0 when it completes the motion. The displacement in vertical direction, which is perpendicular to the horizontal direction. Perpendicular to the horizontal direction, the displacement when it completes the motion equal to 0. Here, consider this way. The displacement perpendicular to the slope, how much will it be when it moves from the initial point x? When it moves from initial point x to the final point y, what is the displacement perpendicular to the slopes? You can see the displacement which is perpendicular to the slope is increasing. You can see that it's increasing, reaching a highest point, then decreasing, finally 0. So here also perpendicular to the slope, in perpendicular slope. So this is the slope in this direction, perpendicular to the slope. The displacement becomes 0 when it completes the motion. That is when it hits the side of the hill. The displacement perpendicular to the slope or perpendicular to the side of the hill becomes equal to 0. One thing, I'm going to use that technique. The second thing, we know the gravitational acceleration is vertically down, that is g. When we consider perpendicular to the slope, I need to resolve it this direction. I need to resolve it along this direction. This is the component I should consider. The actual gravitational acceleration is vertically down, but when I consider any equation perpendicular to the side of the hill, I should consider the component of the gravitational acceleration which is perpendicular to the slope, perpendicular to the side of the hill. So that could be, I know this angle, this is 20 degree, so this will be 70 degree because this is 90 vertically down. So this is 70 degree. So the acceleration in this direction, g sine 70. So that is equal to g sine 70. That's all. By using this, I'm going to find the time, right? The time taken to hit the side of the hill, we're going to find it. We'll compare that time with the A part where we found the time taken to reach the highest point. Simple, very simple. One just two-line answer. By comparing the time, we can decide will it reach the highest point before hitting or after hitting, or will it hit the mountain before reaching the highest point. We are going to find it. Okay, so it's a very simple technique. We can use it here, but not given in the mark scheme, this technique. So what I'm going to do, I'm going to use the equation. So perpendicular, so I'm going to show it like this. I'm going to use the equation. This is 20 degree. I'm going to use it this direction, perpendicular to the slope. I'm going to use the equation S equal ut plus half at squared. I'm using this equation perpendicular to the south side of the hill. So S is 0 when it hits the ground for the whole motion or until it hits the ground. It hits the slope, the side of the mount, side of the hill. So as I said, when it comes back and hits the hill, it will be 0, the displacement, which is perpendicular to the side. The perpendicular displacement is 0. The initial velocity, I need to consider that also perpendicular to the slope. So I know the initial velocity, it's like this, it's given. This is 20 degree. is projected at an angle 40 degree to the horizontal. So this angle with the slope, the angle is 20 degree. This angle is 20 with the side of the hill. The initial velocity is making angle 20 because they said 40 degree with horizontal. So with the slope 40 minus 20, that is 20 degree. So the component of the velocity perpendicular to the initial component of the velocity perpendicular to the slope is 50 sine 20. 50 sine 20 is the initial velocity. So 0 is equal to 50 sine 20 into t plus half. As I told earlier, the gravitational acceleration is vertically down. Again, I am telling it. The gravitational acceleration is vertically down, g. So I need to consider the component perpendicular to the slope. In this direction I need to consider. So the component that I wanted is perpendicular to the slope, this direction. So this angle is 70. So this will be g sine 70. I am using this direction. I am using upwards, but this is downwards, the opposite. So there should be minus. So it should be minus 9.81 sine 70 times t squared. I hope you understood the technique here. So divide the whole equation by t. It's not a quadratic equation because 0 here, t squared. Divide the whole equation by t. So 0 equal 50 sine 20 plus or minus, this minus comes here, minus half in 9.81 sine 70 times t. So solve it, bring it to the left. Again I'll write. I don't need to write all these equations again and again. 9.81 sine 70 into t equal 50 sine 20. Solve it and find the t. So the time taken to hit the side of the slope, that will be 3.71 seconds. Now look at here. This is the time. If it wants to hit the slope, if it wants to hit the side of the hill, it will take 3.71 seconds. But the time taken to reach the highest point, we already found it in the A part, that is 3.28 seconds. 3.28 seconds. So that time taken to reach the highest point, which is 3.28 seconds, that is smaller than this second. That means which one will happen first? The lowest time will happen first. Is it? Because the time taken reach the highest point is 3.28 seconds, and it is smaller than the time taken to hit the ground, 3.71 seconds. So it will reach the highest point before hitting. Before hitting the mountain, hitting the hill, side of the hill. Is it? I feel this is very easy now. Just less work. Only thing these all equations are vector equations, so we can use it any direction, but we need to use the proper component in that direction. So I am using perpendicular to the slope, so the g has to be in perpendicular to the slope, but when I resolve it's coming opposite. I am using away from the slope, but it's the component of the g is this direction, so that's the reason there is minus sign. Okay, question 17. Water is dropped into a container of oil. The water forms small spherical droplets that move slowly downwards. Droplet moves downwards at a constant speed. The flow of oil around the droplet is laminar. State what is meant by laminar. You can say the fluid flow in which the layers of flow never cross each other. So that's the answer for A part, first part. A part, second part, state the condition necessary for speed of the droplet to be constant. We know resultant force must be equal to 0. That also you know that. Okay, B part. Question 17b part. A spherical droplet has a volume of 3.35 10 to the power minus 8 meter cube. Calculate the weight of the droplet, density given. So you know density equal mass over volume, mass times gravity. G is the weight. So it's not a big issue. So that is B part. First part, weight equal. So volume into density is the mass into G is the weight. So volume is given 3.35. 10 to the power minus 8. Density is given 1000. 10 to the power 3 means 1000 into 9.81 Newton. So the answer will be 3.29. 10 to the power minus 4 Newton. That's the weight of the droplet. That's a B part, first part. Yeah. B part, second part. Show that the upthrust on the water droplet when it completely submerged in oil is about this much. Density of the oil given. So we know the upthrust equals, second part, weight of the displaced oil. Is it displaced oil. So the water droplet is put into oil. So the oil is going to be displaced by the water droplet. So upthrust is equal to weight of the displaced fluid. Displaced fluid here inside oil, water is flowing. Water droplet is moving. So the fluid around the water droplet is oil. Okay. So that is again the volume, same volume of the water droplet. Density of the same volume, because water droplet is completely inside oil. So the volume displaced is equal to volume of the water droplet, but density of the oil into G. So again we have to use the same thing, 3.35 10 to the power minus 8. Density of the oil is given as 0.94 10 to the power 3, that is 940 into 9.81 Newton. So the upthrust will be 3.09 10 to the power minus 4 Newton. Calculate the terminal velocity of this water droplet in the oil. Viscosity is given. So the terminal velocity, the forces acting on it. So the third part I will do it here. Yeah, third part I will do it here. So if I draw the free body force diagram for the oil, there will be weight downwards, upthrust upwards, the drag force also upwards, that is 6 pi eta RV. So terminal velocity we put Vt. We assume it's the oil flow, the fluid flow around the water droplet, that is oil flow around the water droplet is laminar. So we can use the Stokes law. You should know the condition to use Stokes law. So at terminal speed, we know the resultant force must be equal to 0. That's the terminal speed is the speed at which acceleration equals 0. So resultant force must be 0. So downwards, we know that mg minus u minus fd equal to 0. So fd equal to 6 pi eta rv. So mg minus u minus 6 pi eta rv is equal to 0, but here we need to find the radius. Radius is not given, so we'll find the radius first, then we'll substitute it here. So we know the volume of the 4 by 3 pi r cube is the equation for volume, that is given as 3.35 10 to the power minus 8. So find r, solve it and take cube root of it. So the radius will get 2 into 10 to the power minus 3 meters. Okay, so at terminal speed, mg minus u minus 6 pi eta r vt equal to 0. Resultant force is equal to 0. So we know the mg, that is we found it 3.29 10 to the power minus 4, upthrust 3.09 10 to the power minus 4 minus 6 pi, the viscosity given 0.11, radius we found it 2 into 10 to the power minus 3 into Vt equal to 0. So solve it, find the Vt. So you will get 4.82 10 to the power minus 3 meter per second. Okay, question number 18. The diagram shows a system used to move a stone block up a ramp. A team of people uses a rope to pull the block at constant speed. So constant speed means no acceleration. The total force exerted by the people upwards is equal to total opposite force. That could be compound of the weight and the drag, the friction together downwards. Anyway, they are about friction, nothing mentioned. We'll see. Height of the ramp is given 4.35 meters. Angle of the ramp to the horizontal 6 degree. Mass of block 2.10 10 to the power 3, that is 2100 kilograms. Speed of block up the ramp. So the speed at which it's moving up is 0.450 meter per second. Total power of the team. So that means the power output, total power of the team means that's the power output from the team. So it's not their power supply. So total power output, that means the power given to the power supplied by the team of people to the block is 6.25 kilowatts. That's the output power from the people. Useful output, we can take that when we consider. Right, so their first part show that the total force that the team exerts on the block is about 14 kilonewton. Okay, so here we know the weight, right? Sometimes students think the component of the weight along the slope down is mg sine 6. So it's moving at constant speed, so the total force must be equal to compound of the weight. We can't say that because there could be friction. Friction is not given. So we'll find the first part. We know the power given by the people, the total power output, the power supplied to the block is P, which is given as 6.25 kilowatts. So we know that power equal, first part, A part, we can say power equal force into speed. So this force is the force exerted by the people. You know work equal, you know the equations given in the data sheet, work equal force into distance moved. Force is the force applied by the people. If we consider power means rate of work done divided by time, that's the power, divided by time. So F into d over t, d over t is the speed, F into v, constant speed. So here they are saying it's moving at constant speed. So P equal Fv, where F is the force exerted by the people. So total resistive force also will be the same because it's moving at constant speed. So the total force exerted by the people we are calculating. So the total opposing force means component of the weight plus friction, that also at those two will be equal to this F. Anyway, so the power of the slope is power of the people is given 6.25 10 to the power 3 equal F into the speed is given 0.4505, find the F. So that is 13,889. So that is approximately 14,000 Newton approximately. So approximately 14 kilonewton. That's A part. B part, determine the total work done by the team. So the distance they are moving, we should find it. So we know the angle, we know the height, so B part. We need to find the distance they move, so we can use sine 6 equal 4.35 over the distance they moved along the slope. I took it d, so d is equal to 4.35 over sine 6, so that is equal to 41.6 meter. So the total work done equal to force applied by the people along the slope up, we found it 14,000 or 13,889 into the distance moved, so that is 13,889, that's actual answer, into distance 41.6, so that will be equal to yes 5.78 10 to the power 5, yeah, 10 to the power 5 joules. Then C part, show that the useful work done on the block is about 900 kilos. So this is the work people they are doing it. So all the work done by them won't be the useful work on the block. So the purpose of this method to raise the block through a height of 4.35 meters at constant velocity. So the useful work means the useful work done by the people will be equal to gain in gravitational potential energy. That means they want to raise the block through a height of 4.35 meters. So the useful work by them is equal to gain in gravitational potential energy equal work done by the people equal gain in gravitational potential energy, that is mgh. So mass of the block we know that is given as 2100, 2.10, 10 to the power 3 into 9.81 into height is 4.35. So the final answer, that is 89,614 joules. So approximately 90,000 joules. So I can say 90 kilojoules. That's a useful work done by the people. Okay, so the last part, D part, determine the efficiency. So the people they are doing work, the useful work only this much. That's the work given to the block in a useful way. But the total work done by the people is this much. So efficiency, we'll find it. So efficiency, you know, useful work over input work. So we'll find it. That's a D part. Useful work by people, or useful work done by people, or useful work done by people, or useful work on the block, we can say work on the block. That's the way the question asks. Useful work on the block. Divided by total work by the people. Into 100%. So useful work on the block, we found it, that is 89,640 divided by total work done by the people, we found it 5.78, 10 to the power 5 into 100%, you'll get 15.5%. That's the answer. Okay, question 19. A large parasol has been set up on a windy day. The center of gravity of the parasol is vertically above the center of the base. The bottom of the parasol starts lift from the ground as shown. The weight of the parasol is given as 110 Newton. The force of the wind is 40 Newton in a horizontal direction. Explain why it will topple. Your answer should include a calculation. So there it's given the diagram. So the A part, the force of the weight is given 40 Newton. Explain why the parasol will topple. Your answer should include the calculation. So we know my diagram little bit more slant, but it's slightly topple, so slightly lifted this way. Okay, so the weight is still passing this direction. The weight is on the right side. The point P indicates the point of the base, which is in contact with the ground. I marked it, I named it as P. Okay, so the distance, the diameter of the base is given as 0.44 meters. So the distance, because small angle, so my diagram shows little more slant. But anyway, the distance from the point P, that's the edge of the base in contact with the ground. From that point P to the perpendicular distance to the weight, I can still take, which is half of the 0.44 meter. My diagram little too much, I drew it, doesn't matter. So this distance I can take as 0.22 meter because they are giving the diameter of the base as 0.44 meter. Okay, so we'll find the clockwise moment about P. Consider moment about P because P is the point at which the base is still in contact with the floor, right? So take moment about P. So P is the point where the base is in contact with the ground or floor. Okay, so the total clockwise moment, we'll consider total clockwise moment, that is equal to 110 into 0.22. So that's the only force providing the clockwise moment, because I consider about P means the normal reaction at the point P won't included into the equation because it's passing through the point P, no perpendicular distance to the normal reaction from P. Okay, so 110 into 0.22, that is equal to 24.2 Newton meter. So total anti-clockwise moment about P, that is equal to 14. This is the only force providing, is the horizontal force. So from P, the perpendicular distance to this horizontal force is 1.80. 14 into 1.80, that's 24.2 Newton meters. So here you can see the total anti-clockwise moment is greater than total clockwise moment. So that means it's going to topple further and further in anti-clockwise direction because anti-clockwise moment is greater than clockwise moment. So what's going to happen when it's going to topple further and further towards left or in anti-clockwise direction? So what will happen? The weight of the whole parasol will shift towards point P. What will happen? The clockwise moment will decrease. So when it starts to topple towards anti-clockwise direction, the distance from P to the weight will decrease. So what will happen? The clockwise moment will become much more larger than anti-clockwise moment. The anti-clockwise moment, which is provided by the wind, will become more and more. So what will happen? It will topple finally in anti-clockwise direction. Or you can say when the weight P passes the point P, it won't be anti-clockwise. The stability will be lost. Either way, we can say. So the final answer we should give since the anti-clockwise moment is greater than clockwise moment, the whole system will lift or topple in anti-clockwise direction and the distance to the weight will decrease. When the distance to the weight decreases, the equilibrium or the condition for stability will decrease when the weight passes point P. Finally, it will topple in anti-clockwise direction. Okay, so this is the question number 19, part B. To prevent the parasol from toppling, a rope is attached to the parasol at 1.5 meter from the ground as shown. So this height, so this is the supporting rope. Okay, that's connected at a height of 1.50 meter from the ground. So the question is, the horizontal force from the wind is now 25. So it's a new force which is 25 Newton, determined by taking moments about the center of the base. They don't need to tell, but they are telling it. Center of the base. The vertical force that the base exerts on the ground. So the force exerted by the base on the ground, we need to find it. Okay, so here the point, the base where it's touching the center of the base, I take it as Q. Okay, so this rope will exert force on it. So it will try to topple to the left. So the rope will pull it towards left. So the tension of the rope at this position is T here. This is the direction of tension. So I'm going to consider the free body force diagram of the parasol. So the free body force diagram of the parasol, if I draw it again, it will be something like this. So here this is the base. So the total weight is acting downwards. The total weight is acting downwards. There's a tension acting here. At this point, the tension is this direction. This is the tension T. Okay, so that's a tension T acting on it. And also there is horizontal force acting here. That is 25 Newton from the wind. So the angle is given 44 degree. This one is 44 degree. So this is 44 degree. Then there will be normal reaction. So the base will push the ground down. Ground will push the base up. The normal reaction will be this direction. I'll make it R, the contact force. So they asked to find the total push given by the parasol on the ground, that is equal to R. You know, according to Newton's third law, when it pushed the ground down, ground will push it up. So these are the forces acting on the parasol. Okay, so I'm going to find the moment about the base, the center of the base, which I named Q. So I'm going to take moment about Q. So when I consider moment about Q, the weight which is passing through the center, I'll take uniform. The weight is passing through the center of the base, and they are saying the normal reaction from the ground is also passing through the midpoint. So they are telling it, so that R also upwards through the center. So I need to find the perpendicular distance to the 25 Newton from the point Q about which I am going to consider the moment. That height we know 1.80. Only thing I need to find the perpendicular distance to the line of action of tension. So the line of action means I can extend the tension any amount. The line of action, this is the line of action. Moment, how do you define? Force into perpendicular distance to the line of action of force. So the perpendicular distance to the line of action of force means that line of action of force is this one. This is the perpendicular distance to the line of action of force. I'll use blue color ink. This is the perpendicular distance to the line of action of force. This length I need to find it. This distance D I need to find it. So this line should end up here at 90 degree. So in this right angle triangle, I need to find the distance D. Is it? T into the distance D, which is drawn from the pivot Q to the line of action of T, is the moment. So how can I find the D? We know this distance. So this distance from Q to this point is given 1.5 meters. So I can name that point as N. So Qn is given 1.50 meter. This is perpendicular line drawn to the line of action of the tension. So I name this base as Qn. I'll name it as X. So Qx, I need to find it. So in this right angle triangle, I can we can say that sine 44 equal d over 1.5. 1.5 is this one. This is the 1. This length from QN or D over QN. So this length is 1.5 in this right angle triangle. So D is equal to 1.5 sine 44. Find that perpendicular distance. That will be 1.04 meter. That's the perpendicular distance to line of action of T from the pivot. Okay, so now we'll consider a moment about Q. So Q is the center of the base. So this will provide, the tension, this will provide, you can keep it here, and that will provide clockwise moment. So T into, is it consider moment about Q, that is T into the perpendicular distance 1.04 and 25 minus 25 into the perpendicular distance to a line of action of 25 Newton is given from Q, that is force is horizontal, the distance is 1.80. There's no other force. These two forces, weight and R, passes through the center. So passes through the Q, so there is no moment about R and mg about Q. So solve it, that is equal to 0 since it's at equilibrium now. Find the tension T. You will get tension T equal 43.2 Newton. 43.2 or 40.3.3 Newton. Right, now that is not the question. So we need to work more. The question is determined by taking moments about the center of base, the vertical force that the base exerts on the ground. Vertical force base exerts on the ground. That means the vertical force base exerts on the ground is same as R. According to Newton's third law, when the base push the ground down, ground will push the base up. So this is the free body force diagram for the this is the free body force diagram. I drew it for the parasol, right? So I need to find the force exerted, the total force exerted by the parasol on the ground is same as the ground, how much it exerts on it. So I need to find the R that will be same as the total force acting downward. So since it's at equilibrium, I need to consider vertically upward direction. So R minus mg, these are the forces acting, R, mg, T, 25. These are the four forces acting on the parasol, right? So I need to find the total vertically. I am resolving to find the R. So R minus mg. So T I found it. So resolve it down. T cos 45. So that is downwards. I am considering upwards. Minus T cos 44. This one won't have any vertical component. Is it? It won't have any vertical component because it's already a horizontal force. So in vertical direction, the resultant force is equal to 0 because it's at equilibrium. It's at rest now. So the resultant force in vertical direction is equal to 0. So find the R. You know the T, you found it. So R is equal to mg, take it to the right. So that we already know 110 plus T, we found it 43.3 cos 44. Find, I'll continue here, find the R. So that is how much? You will get 141.1 Newton. So that is the force exerted by the ground on the parasol. Therefore, total force exerted by the parasol on the ground, force by the base on the ground, that also same as this one, 141.1 Newton. Okay, so I erase the D. So here I can find the D. I am using the whole board. Look little I'll find the d. So here you can use sine 44 equal d over 1.5. This one 1.5. Yeah. So that is 1.04. I already found it. I do it again since I deleted it. Right, okay, erased it, sorry. Okay, so R is 141.1 Newton. So that's the total force exerted by the base on the ground. So that's the free body force diagram that shows all the forces acting on the parasol. So weight, normal reaction from the ground, tension by the rope, and the wind, the force exerted by the wind. So the question is R. Here the force exerted by the base on the ground is same as force exerted by the ground on the base. Okay. Okay, so that's all this October 2021 tape. I hope you understood. Any comments? If you don't understand, you put it in the comments. I'll try to answer when I'm free. Also, I could upload more videos related to theory, small videos related to theoretical explanations of different topics in Unit 1, Unit 4, Unit 5 also. It takes time, but I'll try to do it when I'm free. So you can put your comments if any specific topics you feel very complicated or you have difficulties in understanding. I'll try to upload a video related to that complicated topic. So if you subscribe, you'll get the notification when I upload the videos. Okay, so bye up to now. Bye.